Hey, I thought I'd make a small video about using the step 8 as a way to generate rhythms and trigger patterns basically, and also how I like to add make noise maths to that to create variations on those rhythms. So the step 8 is a very deep module with a lot of different approaches you can take. We are using a very basic implementation here, which is, as you can see, all the sliders are down. We are not using any of that. The only thing we use is the gate outputs that it has for each step, which trigger when the current step is active. And we use that in combination with the somewhat odd, or at least I haven't seen it a lot, the possibility to control the current step with CV. Obviously you can also trigger the step 8 with a clock, but there's also a CV input to control the current stage, as it's called. We have connected all the outputs here, 8 in total, to a variety of percussion sounds. Yeah, those are the ones you hear now in order. So we have a pattern going on that it's coming from the Nibbler, which is down here, just out of view, which currently generates a very simple pattern. So the Nibbler is an interesting module as well. It basically counts from 0 to 15 and just goes down again after that. And it's being clocked by an LFO currently, which is a lot faster than what we hear now. I have also added a sound to the clock signal, so we can hear that, and I will turn it up a bit. So that's the originating clock signal that runs this all. So a nice thing about using maths currently is that it allows us to both attenuate and offset the signal. I'm using the sum output of the maths here, which means that the other channels can be added to the signal, which allows us to offset the output. This is the input of the Nibbler, so this is basically the signal, and we can attenuate that signal. So that leaves us with two possibilities to change the pattern basically. On the display, I have set it up that I added two horizontal lines which represent the step 8's boundaries. Currently I've scaled it and positioned it that the pattern is perfectly in between those lines. But we can obviously scale, for example, or attenuate the pattern as well to make it go above that. And the step 8 responds in the way, as you can see and hear, that it just stays on the, in this case, last step. So any voltage that goes beyond the 5-volt max just doesn't do anything, which in this case leaves an interesting gap in our rhythm. The same goes for when the voltage goes below 0, which we can do by adding an offset, a negative offset in this case. So we are shifting the pattern down currently. So as you can see, whenever the signal's below the bottom line, step 8 doesn't do much apart from indicating that the first step is active. And once it enters the boundaries, it will just behave like it did before, and currently not fully reaching the final stage. So these two options give us a variety of ways to both scale and position the pattern in between those boundaries. And every setting is basically a different pattern, which gives us a lot of ways to make variations on what we have. Now obviously this gets a lot more interesting when the patterns are more interesting than what we have here. So if we just do some changes on the nibbler, we can instantly change our output rhythm. And again, we can position the pattern where we want it to live. Shift it down a bit. Make the scaling a bit bigger. So these shifting patterns that you slowly see moving up, those are typical patterns from the Nibbler module. Scale it even more. Listen to the clock signal along with it to get a bit of a reference. Maybe slow it down a bit. And yeah, that is how I like to bring in some variations when I use the step 8 to create the rhythms like this. So, thank you for watching.